In this example, we want to find the length of the curve y equals natural log of cosine of x over the interval from 0 to pi over 6. So for this, we want to rely on our formula for the arc length of a curve. The arc length is given by the integral from a to b, whatever our bounds happen to be, square root of 1 plus f prime of x squared dx. In this case, our function is natural log of cosine of x. So our derivative, f prime, is going to be 1 over cosine of x, and then by the chain rule, times a negative sine of x, which is negative sine of x over cosine of x, or negative tangent of x. So in this case, 1 plus f prime of x squared is 1 plus tangent squared of x, which is secant squared of x. So then when I take the square root, I basically am getting rid of this squared here because I take square root of secant squared to give me secant. Now, this works because we are on a range where secant is always positive. So square root of secant squared is just secant because we know that secant is positive. So therefore, integral becomes the integral from 0 to pi over 6 of square root of 1 plus f prime squared, so square root of secant squared, or just secant of x dx. And we either use the formula that we had from Calc 1 to know what this answer is, or we can work it out again. The trick with this is that we want to multiply by a convenient form of 1. So we're going to multiply this, secant of x, times secant of x plus tangent of x, divided by secant of x plus tangent of x. So our expression turns into integral from 0 to pi over 6, secant squared of x plus secant of x tangent of x, divided by tangent of x plus secant of x. And what you can see here that the top is the derivative of the bottom. So if I take u to be tangent of x plus secant of x, then du is exactly secant squared plus secant tangent. This becomes an integral of 1 over u du. What are our bounds? If I plug in 0, tangent of 0 is 0. Secant of 0 is 1 over 1 is 1. Tangent of pi over 6 is 1 over root 3. And secant of pi over 6 is 1 over root 3 over 2. So it's 2 over root 3, where this comes out to be square root of 3. So integral then just becomes log of u from 1 to root 3. Since log of 1 is 0, the answer here is just log of the square root of 3. That's how you would set up and find the length of this particular curve using integrals using the formula for arc length.